Welcome, dear listener, to this quiet space, a place for gentle stories crafted for the deep and peaceful hours of the night. Tonight, our journey takes us to the heart of our world, to listen to the slow and ancient rhythm of the earth itself. We will explore the science of volcanoes, not as forces of destruction, but as slumbering giants, the silent architects and gentle breath of our living planet. I'm so glad you are here to share this time. Before we begin our descent into this wondrous world, I would love to know where you are listening from tonight, or perhaps a peaceful thought from your day. Please feel free to share it in the comments below. And if you find solace in these stories, your support in the form of a like and a subscription to the channel means the world. Thank you deeply. And now, let us begin. Let your mind settle, let your body rest, and allow your thoughts to drift with the sound of my voice. And so, we find ourselves settling into stillness, in the quiet comfort of this moment, letting the weight of the day dissolve into the softness of your surroundings. Feel the gentle rise and fall of your own breath, a silent rhythm that has accompanied you through all the moments of your life. And as you do, imagine for a moment the ground far beneath you, a foundation of immense and profound stillness. We think of it as solid, as immutable, the very definition of unmoving. Yet in the vast, slow story of our planet, this surface is but a delicate, fragile crust, a thin and brittle shell, floating upon a hidden, incandescent sea. This is where our story begins, not with fire and noise, but with the quiet, planetary-scale breathing of the world. For a volcano, in its purest essence, is simply a place where the earth exhales, a connection, a conduit from the deep, warm heart of our world to the cool, open air of the sky. It is a sigh, measured not in seconds, but in millennia. Imagine the surface of the earth, not as a single, solid sphere, but as a mosaic of immense interlocking pieces, like the fractured shell of a great cosmic egg. These pieces, the tectonic plates, are constantly in motion, drifting with an impossible slowness upon the hotter, softer layer beneath them, a layer known as the mantle. This movement is so gradual, perhaps only a few centimeters each year, the same speed at which your own fingernails grow, that it is utterly imperceptible to us in our fleeting lives, yet over the course of deep time, it is this silent, inexorable dance that rearranges continents, raises mountain ranges, and opens vast oceans. Beneath this moving crust lies the Earth's great engine, the mantle, a realm of unimaginable heat and pressure stretching down for nearly 3,000 kilometers. It is not a raging liquid ocean as we might first imagine, but rather a thick, viscous solid that behaves like a fluid over geological timescales, churning in vast, slow-moving convection currents, like thick honey warming in a jar. And within this deep, hidden world, in certain places, the rock can melt, giving birth to magma. Magma is the lifeblood of a volcano, molten rock imbued with dissolved gases and crystals, a substance less dense than the solid rock surrounding it, and so it begins a slow, determined journey upwards, seeking release. This journey is one of profound patience, as a body of magma might spend thousands, or even hundreds of thousands of years, resting in a cavern deep within the crust, a magma chamber, before continuing its ascent. And when it finally reaches the surface, it becomes a volcano, a testament to the immense and persistent power of the planet's inner warmth. We often categorize these earthen giants into three states of being, which sound less like scientific classifications and more like chapters in a long and storied life. There are the active volcanoes, those that are currently erupting or are showing signs of unrest, the ones who are in the midst of their powerful exhalation. They are alive with the planet's energy, their breath visible as steam, their voices heard in the deep rumbles that travel through the ground. Then there are the dormant volcanoes, the sleeping giants. They have not erupted in recent history, but they are not gone. They are simply in a state of deep and profound slumber, their inner fires banked low, their magma chambers quietly stirring. They carry the potential for awakening within them, a silent promise of future activity held in a state of peaceful repose. And finally, there are the extinct volcanoes, those who have breathed their last. Their connection to the deep source of magma has been severed, their internal plumbing has gone cold, and they will never erupt again. They stand as silent monuments, weathered by wind and rain, slowly being reclaimed by the forests and the seas, their epic story concluded, leaving behind only the form of their past greatness. To look upon an extinct volcano is to witness a body at perfect rest, its long life of creation and change, now a finished tale written in stone upon the landscape, a final, peaceful silence after ages of stirring. And in this final, peaceful silence, we find not an ending, but a legacy. For the story of a volcano is ultimately one of creation. While we are often captivated by the fleeting, fiery moments of an eruption, the true work of these giants is far slower, far more patient, and profoundly constructive. They are the silent architects of our world, and their medium is the very substance of the planet itself. Let us drift now, in our minds, to a place where this creation is happening right now, a chain of islands born from the sea, perhaps the beautiful Hawaiian archipelago. Here, the volcanoes are of a different nature, not the steep, angry cones of popular imagination, but vast, gentle mountains with slopes so gradual they are barely perceptible. These are the shield volcanoes, and they are named for their resemblance to a warrior's shield laid upon the ground, a shape that speaks not of aggression, but of broad, quiet strength. Their existence and their form are a direct consequence of the unique personality of the magma that feeds them. This lava, known as basaltic lava, is born from the partial melting of the Earth's upper mantle. Its defining characteristic is its low concentration of a molecule called silica, which acts as a thickening agent in magma. With less silica, basaltic lava is incredibly fluid, possessing a low viscosity, meaning it flows with the ease of warm honey or syrup, rather than thick, sticky paste. Because of this fluidity, when a shield volcano erupts, it is rarely an explosive, violent event. The gases dissolved within the magma can escape easily, bubbling away gently without building up catastrophic pressure. The result is what is known as an effusive eruption, a calm and steady outpouring of luminous, red-hot lava that streams down the mountain's flanks in rivers of fire. It is a mesmerizing sight, a process of deconstruction and construction happening all at once. As the lava flows, it consumes the landscape, yet in the very same moment, it is building it anew, extending the coastline, creating fresh, new earth where there was once only ocean. Each flow, once cooled, becomes another thin layer of dark, hard rock, and over unimaginable spans of time, hundreds of thousands of years, these layers build upon one another, again and again and again. It begins on the deep ocean floor, a small vent releasing pillows of lava that cool instantly in the cold, pressurized water. Slowly, eruption after eruption, a great undersea mountain, a seamount, is built. It grows for millennia in the silent darkness, rising thousands of meters from the abyssal plain, until one day its peak breaks the shimmering surface of the water, and for the first time it greets the sun and the air. It has become a new island, a new home for life, a new piece of the world, built entirely by the patient, architectural work of the volcano. To witness this is to understand that the Earth's creation is not a finished act from a distant past, but an ongoing process, a slow and deliberate craft. The shield volcano does not labor in haste. Its work is measured in the steady pulse of its deep magma chamber. Its artistry is written in the slow, graceful lines of cooling rock. It is a powerful reminder that the most enduring and monumental creations are often not the result of sudden, violent acts, but of a quiet, persistent, and gentle accumulation over ages, a slow and steady breath building worlds. It is the Earth as a patient artist, laying down layer after layer, crafting continents and islands with the silent, tireless focus of a master sculptor. And this dark, new land, though barren at first, holds within it a profound promise, a canvas of minerals waiting for the first touch of life. This dark new land, this canvas of cooled minerals, is a testament to the patient, constructive power of the Earth. But the character of this creation, the form it takes, is decided long before the lava ever meets the air, deep within the hidden chambers of the planet. Not all magma is born the same. and a simple shift in its inner chemistry can give rise to a mountain of an entirely different spirit. A mountain that trades the gentle, spreading slope for a steep and noble spire, reaching for the sky. From the quiet architects, we now turn our gaze to the silent monarchs of the landscape, the great stratovolcanoes. Imagine Mount Fuji in Japan, its perfect, symmetrical cone a subject of art and reverence for centuries. Or Mount Rainier, in the Pacific Northwest of the United States, a colossal peak so high its head is perpetually crowned in a mantle of brilliant white ice. These are not the low, broad shields built by fluid lava, but mountains of immense and elegant steepness, their very form telling a story of a thicker, more reluctant substance. Their lifeblood is a different kind of magma, often andesitic or rhyolitic, and its defining feature is a much higher concentration of silica. If basaltic lava is like warm honey, this silica-rich magma is like cold, thick molasses, or even a sticky, unyielding paste. This high viscosity, this resistance to flow, is the secret to the stratovolcano's dramatic form. Instead of spreading out in thin, wide sheets, these thick lavas ooze slowly, cooling and hardening close to the vent, building the mountain upwards, layer by sticky layer. But these eruptions are not always a simple, slow outpouring. Interspersed with these lava flows are explosive eruptions that shatter the magma into fragments of all sizes, from fine ash to large volcanic bombs. This ejected material, known as tephra, falls back to the earth, blanketing the slopes of the mountain. And so, the stratovolcano is born, a composite of alternating layers of hardened lava and consolidated ash. Its steep sides a direct record of its dual nature, both flowing and explosive. This explosive potential comes from another consequence of the magma's thickness. The gases dissolved within it, primarily water vapor, or H2O, and carbon dioxide, CO2, find it incredibly difficult to escape. They remain trapped within the sticky, viscous melt, like the fizz in a bottle of soda that has been shaken. As the magma rises and the pressure from the overlying rock decreases, these gases begin to expand, forming bubbles that fight to get out. But the thick magma holds them fast, and so the pressure builds and builds and builds, sometimes for centuries, turning the magma chamber into a vessel of immense, contained energy. The stratovolcano, in its long periods of dormancy, is a mountain holding a deep, deep breath, its serene, majestic beauty belying the colossal power held in check just beneath its surface. This image is made all the more profound by the sheer height these mountains can achieve. They often tower so high into the atmosphere that their summits exist in a state of perpetual winter, gathering vast fields of snow that compact over time into deep flowing glaciers. Here we find one of nature's most stunning and elemental paradoxes, a mountain of fire wearing a cloak of ice. This union creates a world of breathtaking and dynamic beauty, but it also creates unique phenomena when the mountain's inner warmth begins to stir. If a small eruption occurs beneath the ice, or if heat simply radiates upwards from a rising body of magma, it can melt the glacier from the bottom up, creating vast lakes of water trapped between the ice and the mountain itself. Eventually, this water may burst out from under the edge of the glacier in a sudden, catastrophic flood known as a yokulaup, a torrent of water, mud, and rock that can reshape the entire valley below in a matter of hours. It is a moment where the two opposing natures of the mountain are reconciled, a powerful release where the fire and the ice become one. To stand in the presence of a great stratovolcano is to feel a sense of profound and silent awe, to appreciate a beauty born of immense tension, a perfect, peaceful form sculpted by the containment of unimaginable power. To appreciate such a mountain, to feel its silent, sleeping power, is to understand that its life is not only expressed in grand, cataclysmic eruptions. The immense energy contained within does not always remain perfectly sealed. In its long periods of slumber, the giant breathes, and if we listen closely, if we attune our senses to the landscape at its feet, we can perceive the subtle and gentle signs of its constant inner life. Let us now wander away from the icy summit and the steep, imposing slopes down to the foothills and valleys that cradle the great mountain. Here in the meadows and forests, the ground itself seems to be whispering, offering quiet reminders of the heat that lies just beneath the thin veneer of soil and grass. We might first be guided by our nose, detecting a strange, pungent scent on the air, the smell of sulfur, which leads us to a fissure in the rock from which a plume of steam is gently rising. This is a fumarole, a place where the volcano exhales its gaseous breath directly into the atmosphere. The steam is groundwater that has been heated to boiling by the proximity of the magma chamber, and mixed within it are gases like hydrogen sulfide, which carries that characteristic smell of rotten eggs and sulfur dioxide. To stand near a fumarole is to feel the warm, moist breath of the deep earth, a direct, tangible connection to the hidden furnace below. Following these whispers, we might come across a pool of water with an almost supernatural turquoise hue, its surface placid, but for the steam gently rising from it. This is a hot spring, another expression of the volcano's gentle influence on the world above. Rainwater and snowmelt seep deep into the ground through cracks and faults in the rock, and on its subterranean journey, it is heated by the same geothermal energy that powers the fumaroles. As the water warms, it becomes a powerful solvent, dissolving minerals from the rocks it passes through. Then, now hot and buoyant and laden with this mineral cargo, it rises back to the surface to collect in pools of stunning clarity and colour. The silica it carries can line the pool with a ghostly white crust, while other minerals and heat-loving microbes can paint the water in shades of blue, green, and gold. Not far away, we might find a more curious sight. A pool not of clear water, but of thick, bubbling mud. This is a mud pot, created in areas where there is little water, but an abundance of acidic volcanic gases. These gases rise and attack the surface rocks, breaking them down into fine clay, which mixes with the available water to form a viscous, bubbling slurry. The plopping sound of the gas bubbles escaping the thick mud is a gentle, rhythmic sound, like a slow, primordial heartbeat. And then there is the most dramatic of these whispers, the geyser. In certain places, the underground plumbing of the geothermal system takes on a very specific shape, a series of chambers and narrow constrictions. As water fills this system, the water at the bottom is heated well past its normal boiling point by the hot rock, but it is kept in a liquid state by the immense pressure of the column of cooler water above it. Eventually, it becomes superheated, and a slight decrease in pressure allows it to flash violently into steam, expanding to over 1,500 times its original volume. This sudden expansion forces the entire column of water above it out of the ground in a spectacular, towering eruption of steam and scalding water. And then, the display is over, and the system begins to quietly refill, the process starting all over again with a deep, rhythmic predictability. Whether it is the steady hiss of a fumarole, the quiet warmth of a hot spring, or the periodic roar of a geyser, these are all the voices of the slumbering giant. They are the evidence of its enduring life, a network of gentle communications that connect the cool, living surface of our world with the fiery, molten heart that beats silently, patiently, in the darkness below. These geothermal whispers, the hot breath of the earth made manifest in steam and bubbling mud, are the most ethereal and fleeting expressions of a volcano's inner life. But when the great exhalation is over, and the molten substance of the planet itself has been brought forth into the cool air, what remains is something far more permanent. A new landscape is born, a sculpture garden of strange and wonderful forms, a canvas painted with a palette of pure, elemental colour. The rocks born from a volcano are known as igneous rocks, a name derived from the Latin word ignis, meaning fire. They are, quite literally, children of fire, each one a frozen memory of a time when it was a flowing, incandescent liquid. The story of an igneous rock, its texture, and its character, is written in the speed of its cooling. When magma cools slowly, deep within the Earth's crust, insulated by kilometers of overlying rock, its atoms have ample time to arrange themselves into orderly, crystalline structures. These are the intrusive igneous rocks, like granite, and if you were to look at one closely, you would see a beautiful mosaic of interlocking crystals, glittering facets of quartz, feldspar, and mica, a testament to its long and patient formation in the quiet darkness. But when lava erupts onto the surface, its story is one of haste. Exposed to the cold air or water, it cools rapidly, and the crystals have little to no time to grow. This creates extrusive igneous rocks, like the basalt of the shield volcanoes, which are typically fine-grained, their individual crystals too small to be seen with the naked eye. But within this world of rapid cooling, there exists a whole gallery of unique and fascinating forms. Imagine holding a piece of pumice, a stone so light it feels like a trick of the senses. It is rough to the touch and filled with countless tiny voids, like a sponge made of rock. This is a stone that can float on water. Pumice is born from a frothy, gas-rich lava that is violently ejected from the volcano. As it flies through the air, the pressure drops instantly, and the dissolved gases expand explosively, creating a foam of molten rock, which then cools and solidifies in mid-air, trapping those bubbles forever. It is the petrified breath of the volcano, a solid foam that holds a permanent record of its explosive release. Then, there is its opposite in almost every way. Obsidian. To hold a piece of obsidian is to hold pure, black glass forged in the heart of the earth. It is cool and smooth to the touch, and it breaks with a unique and beautiful pattern known as a conchoidal fracture, leaving behind curved, rippling surfaces and an edge sharper than any steel blade. Obsidian forms from silica-rich lava that cools so incredibly fast that there is no time for any crystals to form at all. The atoms are frozen in place in a disordered, glassy state. For millennia, our ancestors recognized the gift of this natural glass, skillfully shaping it into knives, arrowheads, and ceremonial blades, a direct connection between the geology of the planet and the dawn of human technology. And even in the seemingly uniform plains of cooled basalt, incredible order can emerge. In some places, like the Giant's Causeway in Northern Ireland, a vast lava flow has cooled into a stunning pavement of tens of thousands of near-perfect hexagonal columns, packed together like a great honeycomb. This mesmerizing pattern, known as columnar jointing, is a natural result of slow, even cooling. As the lava cools and contracts, it begins to crack, and physics dictates that the most efficient way to relieve this stress is to form cracks at 120-degree angles, creating a network of hexagons. It is a moment of profound and unexpected geometry, a sign that even in the aftermath of a seemingly chaotic event, a deep and elegant order can prevail. And upon this canvas of dark rock, the volcano adds its final touches of color. Around the steaming fumaroles, the sulfurous gases cool and deposit crystals of pure, brilliant yellow sulfur, encrusting the rock in a vibrant, almost fluorescent hue. The iron within the rocks, when exposed to steam and air, oxidizes into minerals like hematite, painting the landscape in deep reds, oranges, and browns. The volcano, in its final act of creation, is an artist, using the fundamental elements from the planet's deep interior as its pigments, leaving behind a world not of grey ash and black rock, but of rich texture, profound form, and vibrant, enduring colour. This vibrant and enduring artistry we see on the surface is but the final expression of a long and hidden process, the culmination of a journey that begins in darkness and silence, deep within the crust of the earth. To truly understand the character of a volcano, to know why one whispers and another roars, why one paints with black basalt and another with glassy obsidian, we must travel to the source, to the hidden studio where its palette is mixed and its voice is found. And so, let us begin our journey downwards, leaving the sunlit world behind and sinking deep into the solid rock of the mountain's foundation. Kilometers below the surface, we arrive in a place of immense pressure and unimaginable heat, a vast cavern filled not with air, but with molten rock. This is the magma chamber, the heart of the volcano. It is not a simple, raging pool of fire, but a complex and surprisingly dynamic environment, a place of slow, rhythmic, and transformative change. Here, the magma can rest for thousands, even millions of years, and during this long repose, it is not idle. It is evolving, differentiating, its very chemistry being altered by the patient, inexorable laws of physics and chemistry. Imagine this great body of molten rock, a chemical soup containing a wide array of elements, as it begins to cool ever so slightly. Just as water does not freeze all at once, but forms ice crystals first, so too does magma begin to crystallize. But unlike water, magma is a complex mixture, and its different mineral components have different freezing points. The first to crystallize are the minerals with the highest melting temperatures, typically those rich in iron, magnesium, and calcium. Tiny, dense crystals of minerals like olivine and pyroxene begin to form throughout the molten liquid, like the first snowflakes appearing in a winter sky. Because these solid crystals are denser than the magma from which they formed, they begin to slowly, gently, sink. Over countless centuries, they rain down through the liquid rock, collecting in a thick layer at the bottom of the magma chamber. This slow, steady process is known as fractional crystallization, and it is the primary engine of the volcano's evolution. With every crystal that forms and sinks, the composition of the remaining liquid magma is changed. It has been depleted of the elements that formed those first crystals, primarily iron and magnesium, and so it becomes progressively richer in the elements that are left behind, most notably silica. Over millennia, a magma chamber that was once filled with low silica, basaltic magma can evolve, its upper layers becoming a thick, sticky, silica-rich andesitic, or even rhyolitic magma. This is the great secret of the volcano's dual personality. It is how a single source of magma, derived from the deep mantle, can give rise to both the gentle flowing eruptions of a shield volcano, and after a long period of slow cooking and refinement, the explosive, mountain-building eruptions of a stratovolcano. This hidden process is the volcano's heartbeat. It is a slow, rhythmic pulse of cooling, crystallizing, and settling, a deep and patient alchemy taking place in the crushing darkness. The magma chamber is the womb of the mountain, and it is here, in this quiet, gradual transformation, that the future destiny of the volcano, its shape, its power, and its ultimate expression on the surface of the world, is decided. In the quiet, patient darkness of the magma chamber, the Earth is not only deciding the destiny of a single mountain, but is also playing a part in a much grander story. For these chambers of evolving fire are not scattered randomly across the globe. They are often strung together in vast, luminous chains that trace the great fault lines of our world. To understand their placement, we must rise up from the heart of the individual volcano, ascending high above the surface until continents and oceans are laid out below us like a great map. And there, encircling the vast expanse of the Pacific Ocean, we can see it. A brilliant, horseshoe-shaped necklace of volcanoes, a nearly unbroken line of fire stretching for 40,000 kilometers. This is the Pacific Ring of Fire, home to more than 75% of the world's active and dormant volcanoes. It is a place where the edges of the great tectonic plates meet, and where the planet's most profound acts of geological creation and renewal take place. Here, the story is not of a single heartbeat, but of a slow, powerful, and constant planetary embrace. The engine driving this immense circle of fire is a process known as subduction. It occurs where a plate of dense oceanic crust, having journeyed for millions of years across the seafloor, meets the edge of a lighter, more buoyant continental plate. It is not a violent, head-on collision as we might imagine, but rather a slow, graceful, and inexorable descent. The oceanic plate bends and slides beneath the continental plate, beginning a long journey back down into the hot mantle from which it was once born. This is not an act of destruction, but of recycling, a deep and purposeful embrace where the surface of the world is drawn back into its own heart to be remade. As this oceanic plate sinks, it does not go alone. It carries with it a tremendous amount of water, locked away within the minerals of the crust and trapped in the deep layers of seafloor sediment it has accumulated over the eons. As the plate descends deeper into the earth, the temperature and pressure increase dramatically, and this water is squeezed out of the rock, like water being wrung from a sponge. Now free, this superheated water begins to rise into the wedge of hot mantle rock that lies above the descending plate. And here, a moment of incredible geological alchemy occurs. The presence of this water dramatically lowers the melting point of the surrounding mantle rock. In the same way that scattering salt on an icy road causes the ice to melt even when the temperature is below freezing, this water allows the hot, solid mantle to begin to melt at a much lower temperature than it normally would. This process, known as flux melting, gives birth to a new generation of magma, buoyant and full of dissolved gases, which then begins its own slow journey upwards, collecting in magma chambers within the overlying continental crust. It is this magma, born from the meeting of water and the deep earth, that fuels the iconic, steep-sided stratovolcanoes that line the continents and island arcs of the Ring of Fire, from the snow-capped peaks of the Andes in South America to the volcanoes of the Cascade Range in North America, and the beautiful, revered cones of Japan and Indonesia. They are the surface expressions of this deep, hidden embrace. Monuments built by a planetary cycle of renewal, standing as silent witnesses to the slow and majestic process by which the ocean floor returns to the heart of the world to be reborn as mountains of fire. This grand and powerful cycle of subduction, this embrace at the edges of the continents, tells much of the story of our planet's fire. But it is not the only story. If we journey away from these dynamic plate boundaries, out into the vast, quiet interiors of the great tectonic plates, we can find volcanoes that seem to exist in defiance of these rules. They rise in magnificent isolation from the middle of the ocean floor, thousands of kilometers from the nearest continental embrace, posing a beautiful and profound geological puzzle. The Hawaiian Islands are the most famous of these anomalies, a chain of volcanic islands emerging from the center of the vast Pacific Plate. Their existence points to a different kind of volcanic process, one that originates not from the interactions at the surface, but from a source of heat rising from the deepest parts of our world. This phenomenon is known as hotspot volcanism, and its story is one of an ancient, stationary fire and a perpetually wandering surface. The leading theory to explain these isolated volcanoes is the existence of what are known as mantle plumes. Imagine a slender, persistent column of abnormally hot, buoyant rock, rising like the wax in a lava lamp, all the way from the deep mantle, perhaps even from the boundary where the rocky mantle meets the molten iron core of the Earth itself. This plume is fixed in place, a stationary conduit of the planet's primordial heat that has been rising for tens of millions of years. Above it, the great tectonic plates of the Earth's surface are in constant, slow motion, drifting like immense rafts on the underlying mantle. As the Pacific Plate, for example, slowly slides over the stationary Hawaiian hotspot, the intense heat of the plume acts like a powerful blowtorch, melting the base of the rocky plate from beneath. This creates a vast amount of magma, which, being less dense than the surrounding rock, rises through the crust to erupt on the ocean floor, eventually building a massive shield volcano that may one day breach the surface of the sea to become an island. But the story does not end there, for the plate never stops moving. It continues its slow, northwesterly journey, carrying the newly formed volcanic island with it, away from the stationary plume that gave it life. Cut off from its source of magma, the volcano becomes dormant, and then, over millions of years, extinct. Meanwhile, the plate has moved to a new position over the hotspot, and the process begins all over again. A new, active volcano starts to grow on the seafloor, destined to become the next island in the chain. This conveyor belt-like process, repeated over and over for geological ages, has created the beautiful, linear sequence of the Hawaiian Islands. Today, the hotspot sits beneath the southeastern end of the archipelago, fueling the active volcanoes of the big island of Hawaii. To the northwest, the islands become progressively older, lower, and more eroded. Maui, Oahu, Kauai, each one a former site of the active hotspot, now being carried slowly into dormancy and eventual submergence. This chain does not even end there. It continues as a long line of submerged ancient volcanoes, the Hawaiian Emperor Seamount chain, which stretches for nearly 6,000 kilometers across the Pacific floor, a dotted line that beautifully records the exact direction and speed of the Pacific Plate's movement for the last 80 million years. The hotspot is a planetary memory, an ancient storyteller, and the chain of islands it leaves behind is the epic it writes upon the ever-moving face of our world. The story written by the wandering hotspot is one of deep and patient fire, a slow and steady pulse from the planet's core. But not all volcanic stories are written so deliberately. Sometimes, the narrative becomes sudden, sharp, and explosive, especially when the rising fire of the Earth encounters its great elemental opposite, the cool, life-giving presence of water. This meeting, at the interface of magma and hydrosphere, can unleash some of the most dramatic and transformative forces in nature. The ground beneath our feet is rarely dry. It is a porous sponge, saturated with groundwater that fills the countless cracks and voids within the rock. When a body of magma rises close to the surface, its intense heat begins to radiate outwards, and if it encounters one of these subterranean reservoirs, the water can be heated to its boiling point and beyond. If this happens quickly enough, the water flashes into steam, expanding in volume with incredible force. This can trigger what is known as a phreatic eruption, a steam blast explosion. In this event, no new magma is actually erupted. It is simply the violent expansion of heated groundwater that shatters the overlying rock, ejecting a turbulent cloud of steam, mud, and shattered rock fragments. It is the sound of the volcano clearing its throat, a powerful exhalation driven not by the magma itself, but by its potent interaction with the water of the world above. However, when the rising magma and the water come into direct, intimate contact, the result is something far more powerful. This is a phreatomagmatic eruption, a true meeting of fire and water. Imagine a rising column of magma, at a temperature of over 1,000 degrees Celsius, suddenly breaching the floor of a shallow lake, or encountering a deep aquifer of groundwater. In that instant of contact, the immense thermal energy of the magma is transferred to the water with shocking efficiency. The water flashes into steam, not just boiling, but exploding, expanding to more than 1,600 times its original volume in a fraction of a second. This cataclysmic expansion sends a powerful shockwave through both the ground and the magma itself, shattering the molten rock into millions of tiny, sharp-edged particles of ash. The resulting eruption is a dark, violent, and turbulent surge of superheated steam and pulverized rock, a dense, ground-hugging cloud that expands outwards from the vent with incredible speed. It is a moment of pure, elemental fury, a reaction born from the fundamental opposition of these two powerful forces. Out of this brief and violent union, a unique and often serene landscape is born. The blast excavates a deep bowl in the earth, and the rim of this bowl is often low, surrounded by a thin ring of the ejected ash and rock fragments. This formation is known as a maar. Over time, as the memory of the eruption fades, this crater often fills with rainwater and groundwater, becoming a tranquil and perfectly circular lake. Its still, clear waters, giving little hint of the explosive violence that created the basin they now occupy. To gaze upon a maar lake is to witness a profound paradox, a place of immense peace and beauty, born from a moment of unimaginable power. It is a scar on the landscape that has healed into something beautiful, a permanent record of that singular, transformative instant when the heart of the Earth's fire touched the coolness of its surface waters. It is a reminder that in nature there is no true opposition, only interaction, and that even the most violent meetings of elemental forces are ultimately acts of profound and lasting creation. The lasting creation of a maar lake is a story of a power that blasts outwards, but there is another expression of a volcano's energy, a power that does not explode, but flows with a silent, ghostly, and inescapable grace. It is one of the most awesome and surreal phenomena on our planet, a force that seems to defy the very laws of physics as we know them, moving with the speed of an avalanche, the density of a river, and the searing heat of a furnace. This is the pyroclastic flow, a river made not of water, but of the very substance of the mountain itself. Our story begins high on the slopes of a great stratovolcano, in the midst of a powerful, explosive eruption. A vast column of ash and gas has been driven tens of kilometers into the sky, a towering, grey cloud blotting out the sun. But sometimes, this colossal column, so full of dense rock and ash, becomes too heavy for its own upward momentum to support. It begins to collapse under its own weight, or perhaps the eruption itself falters, and this great mass of material comes rushing back down to Earth. Or, in another scenario, a dome of thick, viscous lava building in the crater becomes unstable and collapses, releasing the pressurized gas and ash trapped within. In that moment, the pyroclastic flow is born. It is a terrifyingly beautiful mixture, a turbulent, chaotic cloud of superheated gases, fine ash, and larger fragments of pumice and rock, all moving together as one. The temperatures within can exceed 800 degrees Celsius, and it is not merely falling, it is flowing, hugging the ground and accelerating down the slopes of the volcano at incredible speeds, often faster than 100 kilometers per hour, and sometimes much, much more. The secret to its impossible speed and fluidity lies in a process called fluidization. The hot, expanding gases trapped between all the solid particles act as a lubricant, reducing the friction between them to almost nothing. The countless solid fragments are no longer behaving like a pile of rock, but are instead buoyed by the gas, allowing the entire mass to flow across the landscape with the eerie, frictionless grace of a liquid. It is not a solid, nor a liquid, nor a gas, but some phantom state in between all three. To witness a pyroclastic flow, from a safe distance, is to watch a dream unfold. It moves with a profound and unsettling silence, a low, rumbling hiss, the only sound against its immense speed. It is a roiling grey river of ash that pours down valleys, its leading edge a turbulent cloud of billowing dust, the denser flow behind it glowing with a dull red internal heat. It does not crash and tumble like an avalanche of rock or snow. It flows with a chilling smoothness, overtopping ridges and sweeping across plains with an unstoppable momentum. It is the mountain becoming liquid, the solid earth unmade and sent rushing across itself. And when it finally comes to rest, as its gases cool and escape, it leaves behind a world transformed. It blankets the landscape in a thick, uniform layer of ash and pumice, meters or even tens of meters deep, burying everything it has touched. The world it leaves behind is one of profound and utter stillness, a simplified, monochromatic landscape, erased and then remade by this silent, ghostly river of fire and ash. The silent, ghostly river of the pyroclastic flow is a force that can remake a landscape in a matter of moments, burying valleys and erasing forests under a deep blanket of ash. It is an expression of immense power, born from the collapse of a single volcanic peak. But there exists a scale of volcanism so vast that its expression is not a single river of ash, but a continental flood, a force so profound that it does not merely reshape a mountain, but can alter the course of life on the planet. These are the supervolcanoes, and to contemplate them is to feel the slow, deep, and powerful pulse of the Earth's own life cycle. The term supervolcano can be misleading, as it does not typically refer to a colossal, towering mountain. In fact, many of these immense volcanic centers have no obvious peak at all. They are so large that their form can only be truly appreciated from space. Their defining feature is not a cone, but a caldera, a vast, cauldron-like depression in the Earth's surface, a scar left behind by an eruption of almost unimaginable magnitude. A supereruption is defined as an event that ejects more than 1,000 cubic kilometers of material. To put that into perspective, the powerful eruption of Mount St. Helens in 1980 ejected about 1 cubic kilometer of material. A supereruption is, at a minimum, 1,000 times larger. Let us journey in our minds to the beautiful landscape of Yellowstone National Park in the United States. It is a place of serene forests, vast lakes, and the world's most spectacular collection of geysers and hot springs. It feels ancient, peaceful, and enduring. Yet, this entire landscape of breathtaking beauty is cradled within the caldera of one of the world's largest supervolcanoes. The peaceful geothermal features are but the faint whispers of a giant in a deep and profound slumber, its last great awakening having occurred some 630,000 years ago. The formation of such a caldera is the result of processes that unfold over immense spans of time. Deep beneath the surface, an enormous magma chamber begins to grow, fed by a mantle plume or hotspot. This chamber can be tens of kilometers wide and several kilometers thick, a subterranean sea of silica-rich gas-charged magma. Over hundreds of thousands of years, it slowly swells, pushing the ground above it upwards into a vast, low dome. The pressure within this chamber builds to an incredible degree, until finally, the crust above it can no longer contain the strain. It does not erupt from a single central vent, but from a series of great ring fractures that form around the edge of the swollen dome. In a cataclysmic instant, the superheated, gas-rich magma explodes upwards from these fissures, creating colossal pyroclastic flows that can travel for hundreds of kilometers, burying the surrounding landscape under a layer of hot ash hundreds of meters deep. As the vast magma chamber empties, the roof of rock above it is left unsupported. It collapses downwards, plunging kilometers into the void left by the evacuated magma, creating the Great Caldera. This entire event, from the initial blast to the final collapse, may last for days or even weeks. It is not an act of destruction in the planetary sense, but a form of release, a cyclical process that the Earth seems to undergo on rare occasions. It is like a planetary fever, a moment where the accumulated internal heat of the world breaks through to the surface in a powerful, cleansing, and world-altering exhalation before the giant settles once more into a long and quiet period of healing and sleep. When the Earth experiences such a great and powerful fever, its effects are not confined to the ground. The force of a super-eruption is so immense that it does not just reshape continents, it reaches high into the sky, delivering a breath so powerful that it can change the climate of the entire world. The immediate aftermath on the ground is one of transformation by burial, but the more subtle, more far-reaching, and perhaps more profound consequence is a transformation of the very light that warms our planet. The ash and rock ejected in a great eruption, while devastating to the local environment, are relatively heavy, and most of it falls out of the atmosphere within days or weeks. The true agent of global change is something far lighter and more insidious. The volcanic gases, particularly a compound called sulfur dioxide, or SO2. In a major eruption, millions of tons of this gas are propelled with such force that they bypass the troposphere, the lower layer of the atmosphere where our weather occurs, and are injected deep into the stratosphere, the calm, stable layer that lies above it. Here, far above the clouds and the rain, this gas can linger for several years. Once in the stratosphere, the sulfur dioxide gas begins to interact with water vapor, undergoing a chemical conversion that transforms it into tiny droplets, or aerosols, of sulfuric acid, H2SO4. These droplets are incredibly small, far too small to be seen with the naked eye, but they are incredibly numerous, and together they form a fine, persistent haze that gradually spreads out from the site of the eruption to encompass the entire globe. This stratospheric veil acts like a vast, shimmering shield, and its primary effect is to increase the Earth's albedo, which is its ability to reflect sunlight. The tiny sulfuric acid droplets are highly reflective, and they scatter a portion of the incoming solar radiation back into space before it has a chance to reach and warm the surface of the planet. The result is a gentle but persistent global cooling, an effect often referred to as a volcanic winter. This is not a sudden, dramatic ice age, but rather a subtle dimming of the world, a period of global twilight that can last for years. The days seem a little less bright. The sunsets are often spectacularly colourful due to the scattering of light by the aerosols, but the summers are noticeably cooler, and weather patterns can be disrupted across the planet. We have a poignant historical record of such an event. In 1815, the eruption of Mount Tambora in Indonesia, the largest eruption in recent recorded history, injected a colossal amount of sulfur dioxide into the stratosphere. The following year, 1816, became known across the Northern Hemisphere as the year without a summer. Frosts and snowfalls occurred in June and July in Europe and North America. Crops failed, and the world experienced a prolonged period of cool, dim weather. It is a powerful and humbling reminder of the deep interconnectedness of our planet's systems, a demonstration of how a single, powerful breath from the solid Earth can ascend into the sky, wrapping the entire world in a soft, cool veil, and proving that the story of a single, distant mountain can, for a time, become the story of us all. After the global twilight of a volcanic winter has passed, and the soft, cool veil has dissipated from the stratosphere, our attention returns to the land itself, to the thick blanket of ash and cooled lava that now covers the world. The immediate aftermath of an eruption is a scene of profound stillness and monochromatic simplicity, a landscape that appears sterile, silent, and utterly devoid of life. It is easy to look upon this new world of grey ash and black rock and see only an ending. But buried within this seemingly barren material is a deep and powerful promise. For the volcano, in its final act, has not delivered a curse upon the land, but a gift of immense and lasting fertility. The story of volcanic soil is a story of renewal, a testament to the phoenix-like resilience of life and the surprising generosity that lies hidden within the ashes of the Earth's fire. This new soil, known to scientists as andesol, is initially just raw, unprocessed rock. But as time begins to work, its slow and patient magic, a remarkable transformation occurs. The relentless forces of weathering, the gentle touch of the rain, the persistent push of the wind, and the subtle expansion and contraction from the warmth of the day and the cool of the night, all begin to break down the hardened lava and fine ash. This slow, mechanical and chemical weathering is like the unlocking of a great geological treasure chest. Volcanic rock is born from the planet's mantle, and it is incredibly rich in the primary nutrients that are essential for life to flourish. As the rock breaks down, it releases an abundance of phosphorus, a crucial element for the storage and transfer of energy within a plant's cells. It frees potassium, which is vital for regulating the movement of water and sugars, allowing plants to grow strong and healthy. It provides a host of other essential minerals, such as calcium, magnesium, iron, and sodium, which are often depleted in older, more weathered soils in other parts of the world. Furthermore, the physical structure of this new soil is often ideal for agriculture. The tiny, glassy particles of ash create a soil that is light, porous, and well-draining, preventing roots from becoming waterlogged, while at the same time possessing a unique ability to hold onto a great deal of moisture, providing a steady supply for plants during dry periods. And so, over decades and centuries, life returns, not just with tenacity, but with an astonishing vigor. The first pioneer species give way to grasses, then shrubs, and finally forests, all thriving in this nutrient-rich medium. And wherever these soils exist, humanity has long followed, recognizing their profound gift. Some of the world's most renowned agricultural regions are situated on the fertile slopes of volcanoes. The rich, dark earth on the high plains of Central and South America produces some of the world's finest coffee beans. The sun-drenched flanks of Mount Etna in Sicily and Mount Vesuvius in Italy are covered in lush vineyards that have produced celebrated wines for millennia. The terraced paddies that climb the volcanic mountains of Indonesia and the Philippines yield abundant harvests of rice, feeding millions. It is a beautiful and enduring paradox that the very same mountains that can bring such sudden and dramatic change are also the source of such long-term abundance and stability for the civilizations that have the courage and wisdom to live in their shadow. The volcano, it seems, is the ultimate agent of renewal, a force that scours the landscape clean only to bestow upon it a foundation for a richer, more vibrant, and more abundant future. This profound generosity of the earth, this gift of fertility born from fire, is a story we can read in the sunlit world of fields, forests, and vineyards. But the creative power of volcanoes extends far beyond the reach of the sun, into the deepest, darkest, and most mysterious realms of our planet. To find it, we must leave the familiar surface behind and begin a journey downwards, sinking through the cool, blue waters of the ocean, past the twilight zone, where the last rays of light fade into nothing, and into the crushing blackness of the abyssal plain. Here, kilometers below the surface, the pressure is immense, the water is near freezing, and there is no light, save for the faint, ghostly glow of the occasional bioluminescent creature. It is a world that for centuries we believed to be a vast, cold, and lifeless desert. But in the late 1970s, a discovery was made that would forever change our understanding of life itself. For it was here, in this seemingly hostile void, that humanity first laid eyes on the deep-sea volcanoes and the impossible oases of life that cling to them. Along the mid-ocean ridges, where tectonic plates are pulling apart and new crust is being formed, we find these extraordinary features known as hydrothermal vents. Imagine a towering, chimney-like structure, sometimes tens of meters high, sculpted from minerals deposited by the vent itself. From its peak billows a dense, black cloud that looks like smoke, earning them the name black smokers. But this is not smoke. It is seawater that has seeped down through cracks in the ocean floor, where it is heated to extreme temperatures, sometimes over 400 degrees Celsius, by underlying magma. This superheated water is then shot back up into the ocean, laden with dissolved minerals like iron, copper, zinc, and, most importantly, hydrogen sulfide. When this searingly hot, mineral-rich fluid meets the near-freezing, oxygenated seawater, the minerals precipitate out of the solution instantly, creating the cloud of black particles and building the chimneys, layer by layer. In this world of absolute darkness, photosynthesis, the foundation of all life on the surface, is impossible. Yet these vents are teeming with life. The discovery of these ecosystems revealed an entirely new way of living, powered not by the light of the sun, but by the chemical energy of the earth itself. This process is called chemosynthesis. The foundation of this incredible food web is a vast community of bacteria and archaea, organisms known as extremophiles, which thrive in these seemingly hellish conditions. They have evolved the remarkable ability to harness the chemical energy stored in the hydrogen sulfide gushing from the vents. They use this energy to convert carbon dioxide into organic matter, becoming the primary producers for an entire, self-contained ecosystem. And what an ecosystem it is! Here we find giant tube worms, some over 2 meters long, with no mouth and no gut, that host these symbiotic bacteria within their bodies and are recognizable by their brilliant red plumes. We see ghostly white crabs scuttling over the rocks, dense beds of mussels and clams, and strange, pale fish, all flourishing in the warm, nutrient-rich waters surrounding the vents, a vibrant, bustling city of life in the midst of an endless, silent desert. This stunning discovery led to an even more profound hypothesis, that perhaps, in the early days of our planet, it was in the warm, energy-rich, and chemically complex environment of these deep-sea volcanoes that the very first sparks of life on Earth ignited, making these hydrothermal vents not just an oasis for life, but its very cradle. In the deep, sunless cradles of our own oceans, we may have found the very blueprint for life, a profound connection between the Earth's inner fire and the dawn of biology. This creative, world-shaping impulse, this expression of a planet's internal heat, feels so fundamental to the story of Earth that it is easy to imagine it as uniquely our own. But as we lift our gaze from our own world, out into the vast, silent darkness of the solar system, we discover that this language of fire and ice is not spoken by Earth alone. It is a universal tongue, a common story told by worlds of all shapes and sizes, each in its own unique and wondrous dialect. Volcanism, it seems, is a fundamental process of being a planet, a way for a celestial body to express its own geological life. Our cosmic tour begins with our rusty neighbour, Mars. There, on the Tharsis Bulge, stands a monument to a volcanic past so epic it dwarfs anything on Earth. This is Olympus Mons, the largest known volcano in our solar system. It is a colossal shield volcano, so vast that its base would cover the entire state of Arizona, and so tall, at nearly 22 kilometers high, that its summit rises above the thin Martian atmosphere. Its immense size is likely a consequence of Mars's static geology. Lacking the restless movement of plate tectonics, the Martian crust remained fixed over a powerful hotspot for perhaps billions of years, allowing this single mountain to grow, layer by patient layer, to a scale that is almost beyond our comprehension. Today, it is a silent, ancient giant, its fires having gone cold hundreds of millions of years ago, a quiet testament to a time when Mars had a warmer, more dynamic heart. Journeying further out, to the frigid realms of the gas giants, we encounter a form of volcanism so strange it redefines the very word. This is cryovolcanism, the eruption of ice volcanoes. On these frigid moons, water ice is as hard as rock, and the role of molten silicate rock is played by a slushy, liquid mixture of water, ammonia, and methane. On Neptune's largest moon, Triton, the Voyager 2 spacecraft photographed dark, wind-swept plumes rising from a surface of frozen nitrogen, a ghostly eruption of ice and gas in a world where the surface temperature is a mere minus 235 degrees Celsius. And then there is Saturn's tiny, brilliant moon, Enceladus. From a series of long, parallel fissures near its south pole, nicknamed tiger stripes, great geysers of water vapor and ice crystals erupt continuously into space, feeding Saturn's faint E-ring with their fine, frozen dust. This stunning discovery points to the existence of a vast ocean of liquid water hidden beneath the moon's icy shell, a dark, volcanic, and possibly life-bearing sea, making it one of the most compelling places to search for life beyond Earth. But for the most dramatic and relentless volcanic display in the solar system, we must travel to Jupiter's innermost Galilean moon, Io. It is not a slumbering giant, but a world in a constant state of volcanic torment. Its surface is a chaotic psychedelic canvas of yellows, reds, oranges, and blacks, with no impact craters to be seen, for the landscape is being constantly repaved by its more than 400 active volcanoes. These volcanoes spew vast plumes of sulfur and sulfur dioxide hundreds of kilometers into space. The engine driving this infernal activity is not internal radioactive decay, but the immense gravitational power of Jupiter itself. Io is caught in a relentless gravitational tug-of-war between the colossal planet and its other large moons, a constant flexing and kneading that generates tremendous frictional heat within its interior. To look upon the volcanoes of our solar system is to appreciate the sheer diversity of planetary expression, and in doing so, to see our own world's volcanism in a new light. Not as a chaotic force, but as a balanced, life-giving, and profoundly precious feature of our rare and beautiful home. And so, we return from our grand and wondrous tour of the cosmos, from the icy geysers of Enceladus and the sulphurous fires of Io, back to the familiar blue and white marble of our own planet. Seeing the diverse and often violent volcanism of other worlds allows us to appreciate the unique character of our own slumbering giants, the quiet potential and the life-giving nature of the Earth's fire. We live on a dynamic and breathing world, and our relationship with these mountains is not just one of distant awe, but of intimate coexistence. And in this coexistence, we have learned not to fear their sleep, but to listen to it, to attune ourselves to the subtle rhythms and quiet murmurs of the living rock in a gentle science built on patience and profound respect. This act of listening is the heart of modern volcanology. To monitor a dormant volcano is like being a physician attending to a sleeping patient, using sensitive instruments not to predict the future, but to understand the present, to know the difference between a deep, peaceful slumber and the first, subtle stirrings of a restless awakening. One of the most important ways we listen is by feeling the very heartbeat of the mountain. Scientists place arrays of highly sensitive instruments, called seismometers, on the flanks of a volcano. These are not just for detecting large earthquakes, but for perceiving the faintest of tremors that shiver through the ground. They can detect the signature of rock fracturing as magma forces its way upwards, or the unique vibrational frequency known as a harmonic tremor. This is a steady, continuous humming or rumbling, often too faint for a human to feel, which is thought to be the sound of magma resonating as it moves through the volcano's intricate underground plumbing. It is, in essence, the song of the mountain, a direct indication of the movement of its lifeblood. We also watch the mountain breathe. As a magma chamber deep underground begins to fill and pressurize, it gently pushes up on the overlying rock, causing the surface of the volcano to swell and bulge upwards. This inflation is incredibly subtle, perhaps only a few millimeters or centimeters over the course of months or years, but it can be measured with extraordinary precision using a network of global positioning system, or GPS stations, sensitive tiltmeters that measure the changing slope of the ground, and satellite-based radar that can map the deformation of the entire volcanic edifice from space. To watch this slow, almost imperceptible swelling is to observe the deep, long inhalation of the giant as it stirs in its sleep. And, of course, we pay close attention to the giant's breath itself. Volcanologists will travel to the steaming fumaroles on a volcano's crater rim or flanks to carefully collect and analyze the gases being released. The composition of this breath can reveal crucial information about what is happening deep below. A sudden increase in the amount of sulfur dioxide relative to other gases, for example, can be a sign that a fresh, gas-rich body of magma is rising closer to the surface. And we monitor the water, the way the temperature and chemistry of hot springs and crater lakes can change in response to new inputs of heat and gas from below. All of these streams of data, the seismic whispers, the slow swelling of the ground, and the changing chemistry of the air and water, are woven together into a portrait of the volcano's current state. It is a science that is not about certainty, but about understanding, a quiet and patient conversation between our fleeting human curiosity and the vast, deep, and ancient life of the Earth. This quiet and patient conversation between scientists and the slumbering giants is a relatively new chapter in a much older story. For as long as humanity has existed, we have been in a different kind of dialogue with these mountains of fire. A conversation written not in data and charts, but in myth, in art, in ceremony, and in the very fabric of our cultural identities. To live in the shadow of a volcano is to exist in a state of profound and intimate connection with one of the planet's most powerful forces, and this relationship has shaped human consciousness in deep and beautiful ways. From a detached perspective, it might seem a paradox that people would choose to build their homes and their lives on the fertile flanks of a dormant or active volcano. But this choice is rarely born of ignorance. It is born of a different kind of wisdom, a deep and intuitive understanding that the same forces that carry great risk also bestow great gifts. The rich soils, the accessible geothermal energy, the profound beauty of the landscape, and the powerful sense of place and identity that the mountain provides all weigh into a calculation that is as much about the spirit as it is about survival. Across the world, cultures have woven volcanoes into the very center of their spiritual cosmologies, transforming a geological feature into a divine ancestor, a powerful deity, or a sacred gateway. In the Hawaiian archipelago, the volcanoes are the physical embodiment of the goddess Pele, a powerful and passionate creator. Her fiery lava flows are not seen as random acts of destruction, but as the deliberate and sacred act of giving birth to new land. She is a divine and sometimes tempestuous matriarch, and to live in her presence is to be in a constant relationship with a living, breathing, and deeply respected creator force. The threads of cooled lava, which tourists often take as souvenirs, are considered to be her body, and to remove them is a profound act of disrespect, a misunderstanding of the deep, familial connection between the people and the land that Pele continually creates for them. In Japan, the serene, perfect cone of Mount Fuji is not merely a mountain, but a kami, a sacred spirit or god in the Shinto tradition. It is a place of immense spiritual power, a portal between the heavens and the earth. For centuries, artists and poets have sought to capture its sublime beauty, its form a national symbol of purity and endurance. Pilgrims climb its slopes not for sport, but as a spiritual act of purification and reverence, a journey to a place that is both a part of our world and a gateway to another. In the ancient myths of Greece, the mighty volcano of Mount Etna was believed to be the location of the forge of Hephaestus, the god of fire, metalworking, and craftsmanship, its eruptions, the sparks and smoke from his divine smithy. These stories, these beliefs, are far more than simple superstitions. They are sophisticated and enduring psychological frameworks that allow humanity to coexist with immense and unpredictable power. They transform a source of potential terror into a source of meaning, identity, and profound spiritual connection. To live in the shadow of a great volcano is to be reminded daily of forces far greater than oneself. It is a relationship that fosters a deep humility, a powerful respect for the cycles of creation and destruction, and a constant awareness of the sublime, that feeling of awe, wonder, and reverence in the face of a beauty that is both magnificent and terrifyingly powerful. This deep, human connection to the volcano, woven through the timescales of culture and mythology, is a story of how these mountains shape our sense of place. But they also have a profound ability to shape our sense of time itself, offering us one of our most powerful tools for reading the vast, deep, and almost unimaginable history of our planet. The life of a human, or even a civilization, is a fleeting moment against the slow, patient life of a mountain. And it is the volcano, with its periodic breaths and its enduring substance, that provides us with a clock, a calendar that allows us to look back into the abyss of deep time. One of the most elegant ways it does this is through the science of tephrochronology. The word tephra is Greek for ash, and tephrochronology is the study of time using layers of volcanic ash. When a large volcano erupts explosively, it can send a vast cloud of ash high into the atmosphere, where it is carried by winds over thousands of square kilometers. As this ash gently settles back to Earth, it forms a single, thin, and continuous layer over the entire landscape. This layer has a unique chemical fingerprint, a specific mix of elements that is like a signature for that one single eruption. For a geologist or an archaeologist, finding such a layer is like finding a dated page in the great book of the Earth. If this ash layer is found in the sediments at the bottom of a lake, in the slowly accumulating layers of a peat bog, or just above an ancient human settlement, it becomes a perfect time marker. Everything below that layer is definitively older, and everything above it is younger. By identifying the same layer in different locations, sometimes hundreds of kilometers apart, scientists can precisely correlate events, knowing with certainty that a change in a forest's pollen in one location happened at the exact same time as a flood event recorded in a river valley in another. The volcano, in a single, powerful exhalation, provides a moment of synchronicity across the entire landscape. This volcanic calendar is recorded with even greater precision in the great ice sheets of Greenland and Antarctica. Here, scientists can drill down for kilometers, extracting long cores of ice that contain a perfect, layered record of snowfall, stretching back hundreds of thousands of years. When a large volcanic eruption occurs anywhere on the planet, its sulfurous gases form a stratospheric veil of sulfuric acid, which eventually falls out and is deposited on the ice, creating a distinct, highly acidic layer. By counting the annual ice layers downwards, like counting tree rings, scientists can date these past eruptions to the very year, and sometimes even the season, in which they occurred. And to measure time on an even grander scale, to know the age of the volcano itself, we can listen to the quiet, steady ticking of an even more profound clock, the decay of radioactive atoms locked within the volcanic rock. When lava cools and solidifies, it traps a certain amount of the element potassium, including a radioactive isotope, potassium-40. This isotope decays at a perfectly known and unchanging rate into the inert gas argon. By carefully measuring the ratio of potassium-40 to argon gas trapped within the rock's crystals, scientists can calculate with remarkable accuracy how much time has passed since that rock cooled from a molten liquid into a solid. This method, known as potassium-argon dating, allows us to reach back millions, even billions of years, revealing the age of ancient lava flows that form the bedrock of our continents. To contemplate this is to feel the immense, silent, and peaceful expanse of deep time, a timescale measured not in hours or days, but in the steady, patient transformation of the very elements of the universe, a perspective that can quiet the mind and place our own fleeting moment within a truly vast and magnificent story. To contemplate the vast, silent expanse of deep time is to find a unique and profound kind of peace, a quietening of the soul. And nowhere is that sense of primordial stillness more present, more tangible, than on the surface of a new and barren lava flow. Here, after the roar of the eruption has faded and the incandescent heat has bled away into the sky, what is left is a world paused, a landscape where time itself seems to have stopped. A profound silence settles over the land, a silence deeper than any you have ever known, for there is nothing here to make a sound. There are no leaves to rustle, no insects to buzz, no birds to sing. There is only the stark, black rock and the sky. The world has been reset to zero, a sterile canvas awaiting the first, patient touch of life's return. This process of return, known as ecological succession, is one of nature's most beautiful and hopeful stories. It is not a frantic struggle, but a slow, graceful, an utterly unstoppable reclamation. The very first to arrive in this new world are the pioneers, organisms of incredible resilience and simplicity. Often, they are lichens, a remarkable and ancient partnership between two different life forms, a fungus and an alga, woven together into a single being. The fungal partner provides the anchor, its hardy filaments capable of gripping the bare, glassy rock and secreting gentle acids that begin the impossibly slow process of breaking it down, extracting the barest traces of mineral sustenance. The algal partner, in turn, performs the miracle of photosynthesis, capturing the energy of the sun and creating sugars to feed them both. They spread across the black rock in slow, circular patches of dusty green, vibrant orange, and pale grey, the very first strokes of colour on the sterile landscape. They are life's first patient foothold, and in their slow and humble existence, they are preparing the way for all that will follow. As they live and die, their tiny bodies, combined with the wind-blown dust they trap, begin to form the first, almost invisible grains of soil. Into the tiny cracks and hollows they create, the next pioneers arrive, the mosses. They anchor themselves in this primitive soil, their soft green cushions acting like tiny sponges, trapping precious moisture and adding their own small contribution of organic matter to the growing film of new earth. After the mosses, perhaps years or decades later, the first vascular plants may find a home. Hardy ferns, their spores carried on the wind from miles away, might find purchase in a shaded, damp crevice. The seeds of tough grasses and wildflowers, equipped with feathery parachutes, drift in and find a place to germinate. And so, the landscape begins to change. The stark, uniform blackness is slowly softened by patches of green. And with the plants come the first insects, and with the insects, the first birds. Each new arrival alters the environment, making it more hospitable for the next, in a slow and collaborative chain of creation. Eventually, after centuries, the soil may be deep enough to support shrubs, and then, after millennia, the first trees of a new forest will rise towards the sky. To witness this process, even in our imagination, is to meditate on the profound beauty of patience and the unstoppable power of life's quiet persistence. The dormant volcano, and the land it has made, becomes a symbol of potential, of a silence that is not empty, but is full of the deep and certain promise of renewal. This slow and certain promise of renewal, of life patiently returning to a world scoured clean by fire, is the final chapter in the volcano's story on the landscape. It is a fitting and peaceful end to our long journey, a journey that has taken us from the gentle, sunlit surface of our world down into its molten heart, that has carried us on rivers of ash and through global twilights, that has lifted our gaze to the icy volcanoes of distant moons and brought it back to the quiet, spiritual reverence of those who live in their shadow. We have been listening to the story of the slumbering giants, but as we settle now into our own final moments of stillness before sleep, we may come to feel that this great and ancient cycle of slumber, of awakening, and of renewal is not just a story of the earth. It is a pattern that resonates, in a soft and metaphorical way, deep within ourselves. The ultimate engine driving this entire epic story is the Earth's simple and profound need to release its own inner warmth, the primordial heat left over from its violent formation, and the steady, gentle warmth generated by the slow, radioactive decay of elements deep within its mantle. This is the planet's fire, its fundamental, creative, and life-giving energy. And perhaps it is not too bold to suggest that we, too, have a fire within. Our own inner worlds are shaped and driven by deep, often unseen forces, by the warmth of our passions, the spark of our creativity, the slow burn of our memories, and the molten stirrings of our emotions. The immense pressure that builds in a magma chamber over millennia, as it quietly differentiates and evolves in the darkness, can feel like a reflection of the silent, internal pressures of our own lives, the periods of quiet contemplation and hidden growth that prepare us for our own moments of change. The eventual eruption, the release of this long-held energy, can be seen in our own moments of profound creative expression, of deep emotional release, or of great personal transformation the moments when that which has been held within is finally brought forth into the world. And the new land that is created, the new soil that holds such fertile promise, is like the new perspectives, the new strengths, and the new opportunities that can emerge in our own lives after a period of intense and powerful change. The long and essential periods of dormancy, the great silence after the roar, are mirrored in our own deep need for rest, for recovery, for the quiet, fallow times in which our own energy is restored and our own inner landscape is slowly, patiently renewed by the gentle return of inspiration and peace. The story of the volcano teaches us that these cycles are not just natural, but are essential. The fire and the stillness, the roar and the silence, the creation and the renewal are all parts of one single, beautiful, and ongoing process. The same fundamental elements forged in the hearts of dying stars make up both the igneous rock of the mountain and the soft tissues of our bodies. The same universal laws of physics that govern the flow of lava also govern the steady, quiet beating of our hearts. We are not separate from this great, breathing planet. We are a part of it, a living, feeling, and conscious expression of its own deep, ancient, and fiery creativity. And so, may you feel that connection now, as you drift into the quiet darkness. May your rest be deep, and your dreams be filled with a sense of wonder and of peace. Thank you for sharing this journey with me tonight. If you have found a moment of calm here, I would be so grateful for your support with a like, a subscription, and perhaps a comment sharing your thoughts. Your presence here makes all of this possible. Sleep well,